Hello students, welcome to the one of the most important segment of microwave. In this segment, we are going to discuss microwave tubes. But before discussing today's session, let me ask you a simple question. Why microwave tubes? Why not ordinary tubes or traditional tubes? Can you give me the answer? No? Okay. Let us discuss them. So what are the traditional tube? They are diode, it may be triode or it may be pentode, but it is not operated at microwave range frequency, that means at high frequency. Why? There are some reasons. Number one reason, due to the inductance and the capacitance effect. What you already aware of, that XL equal to J omega L. So at high frequency, it may act as an infinite resistance, which is not possible in practice. And Xc is equal to 1 by J omega C. So at high frequency, this Xc will convert it to 0. That means total short circuit. So the traditional microwave tube is rejected for this point. Second point is transit time effect. That means here we are using high frequency. As the frequency is high, there is no amplification effect of the signal or the information. So, with respect to the second point, traditional tube is again rejected. The third point is skin effect. At high frequency, the signal is transmitted through the surface of the waveguide. It is known as skin. Now, at such high frequency, resistance is proportional to root over F. So, as the frequency is high, the resistance becomes so high that the signal will not able to propagate. So, all the traditional tube is rejected. The microwave tubes are two-cavity klystron tubes, multi-cavity klystron, magnetron, and traveling wave tube. Now, can you answer me which type of the tube is used more in our practical life? No? Okay, let me give you the answer. The answer is magnetron. The magnetron is used in microwave, in airbase, and all the real life fields. Now, today we are going to discuss this two-cavity klystron first. Two-cavity klystron tube is basically one glass material. Here, one electron gun is used to generate the electron and a collector, that is the anode, is used to collect those electrons. Here two cavity is used, that's why the name is two-cavity klystron tube. This kind of the device can generate electron as well as can amplify the electron. The distance between the two cavity is known as drift space. And there are also two electron branches around this two cavity. The electron is generated from electron gun and it is amplified and collected to the collector. Here a radio frequency or RF frequency is applied along the first cavity and the signal is collected along the second cavity. This first cavity input is known as RF in and the output is known as RF out. In two cavity klystron, there are three types of the electron is used. That means three types with respect to the velocity of the electron. The first one is latter electron between the electron gun and between the first cavity. Here the electron velocity is less, that's why the name of the electron is denoted by latter electron. The electron in between the two cavity is known as reference electron. That means this velocity is used as a reference for this two cavity klystron. And the electron in between the catcher and the collector is known as early electron. Here the velocity is high. Now these three type of the electron are bunched together to amplify this RF signal. That is the main utility of the two cavity klystron tube. Now let us discuss the bunching with respect to the graph of the two-cavity klystron tube. Let us discuss the graphical structure of this two-cavity klystron. It is Applegate diagram of the two-cavity klystron. Here, when the electron El comes into the picture, the velocity is high. That means V is greater than V naught, which is the reference voltage. Whenever the electron is EP, that means at the origin, here the velocity is equal to the reference voltage. That means V is equal to V naught. Also, when the electron is E suffix capital E, electron velocity is deteriorated. That means V is less than the V naught, that means less than the reference voltage. Now, these three velocities is bunched or combined in the drift space. By this combination, the RF signal is amplified in magnitude. That is our main motto of this two-cavity klystron, and it is the operating principle of the two-cavity klystron. Now, if you want to improve the efficiency, you will try to perform the amplification action in multi-cavity klystron and the magnetron. This multi-cavity klystron, magnetron, also the traveling wave tube will be discussed in our next lecture. Till then, practice the principles of the two-cavity klystron, work very hard, and if you have any confusion and doubt, you can email us and call us. That's all for today. Thank you, students. Bye.